Welcome to this tutorial number 2 under complex numbers. We move on. Let's see what question we are dealing with. Okay, find two decimal places the modulus and argument in radians of z is 2 plus 7i. So our complex number is z equal to 2 plus 7i. So question is, how do we find the modulus? Now, the modulus of a complex number, okay, the modulus of a complex number z is denoted by this and is given by the square of x component and the square of the y component. So the same way we know this is our x and that is our y. We ignore the i. Okay. So in this case, we have this means that we're looking for the modulus of 2 plus 7i, which will be 2 squared plus 7 squared. And this will give us, this is 4 and 49, which will give us 53. And the square root of 53 is 7.28. I'll leave this one to 2 decimal places. You are done. The argument is the angle, actually. The argument is the angle. And the argument of any vector, all right, is given by theta is equal to tan inverse of the y component over the x component of that particular complex number that you're dealing with. And in our case, this would be tan inverse. Now they have told us to say in radians. So if you're using calculator, go on mod, keep on pressing mod until you see something written rad, then you click whatever number will be below that. Yeah, like in my calculator, if I click mod twice, there will be the second screen which will show me rad, and the number below rad is 2. So I place 2, meaning whatever angles I'll be finding, they'll be in radians. So I put 7 over 2. And in rads, it is going to give you as a number. All right. So I'm getting 1.2924. I'll leave it to 2 decimal places as well. So 29. I'll leave it to 2 decimal places. And that's all. Okay. And if you were told, let's say, to draw the Argand diagram, let me show you how it will be. So the Argand diagram would look something like this. As you can see, this is the theta that we are looking for there. And this is the 2 coming from here. Where? Here. And the 7 is in the complex axis. This is a complex axis, remember that. This is a 7 that you are seeing there. And that is a 2,7. Like that. Meaning this angle here is actually in radians. If you transform it into degrees, it will be maybe like 70 something, if I'm not mistaken. Okay, let's look at another question. Next example, find to 2 decimal places the modulus and argument in radians of z negative 4 minus I. Now here we need to take into consideration the signs, all right? So let's look at the solutions. So step 1, let's first draw the Argand diagram, okay? Let's first draw the Argand diagram. So let me paste it here so that we see what diagram we are dealing with. So this is the Argand diagram, okay? So you can see the complex, so the x-axis is not complex. So this is the negative 4 that we are seeing from there to this side, this, because we are in the negative part. And in terms of the y component, it will be negative 1. So this is why it is down here. So the angle we are looking for, we can say is this one, right? Well, now take note here. We are in the third quadrant. We are in the third what? Quadrant. And in the third quadrant, what is the value of tan? Tan is positive here in the third what? Quadrant. So here's the thing. When you are finding the modulus may not be a problem, all right? It may be the easiest thing to do here. So the modulus of z is just equal to -4 squared, -1 squared, to give us root of 17, and this will give us the modulus as 4.12 to decimal places. But if we are looking for the argument, we understand to say it will be tan inverse of, so now remember that all these are negative, so it will be -1 over -4, and this will give us tan inverse of 1 over 4. And because of that, our reference angle in radians, by what this is in radians, I'm getting 0.24. Yeah, 0.24. So this is in radians. But the question is this the correct one? If you look at what has been given, if I transform this angle, okay? If I transform this angle into not being in radians, I get something like this. I'm getting 14 degrees. Now, 14 degrees is actually in the first quadrant, somewhere there. I'm just approximating. It's quite smaller, by the way, than I'm drawing it. So it can be maybe like this. Now, but the angle we're looking for is actually in the third quadrant. So what do we do? What do we do in that case? Well, here's what we do. So the theta that we are looking for, or the argument rather, in the third quadrant, all right, you always do this. It will be negative, then you say pi minus the reference angle. That's all. If you're looking for the angle in rods in the third quadrant, here's what you do. So negative, open brackets, pi minus 0.24. Now understand that pi, okay, pi is like what? 3.1 something. Tefio. So punch the same way. Pi, you know it on the calculator, it's there, just punch it. So I'm getting 2.9. So if I'm getting 2.90, negative in fact, yeah, radians, what does the negative tell me about the direction? Well, it just means that we are moving clockwise from the positive real axis, all right? Meaning that's why it's negative. So the movement, remember, clockwise is like this. So we are moving from the positive real axis. So that movement is negative. Okay.